Welcome to class number 8. In this class, we will see how we can connect two PCs in different network. In the last class, we have seen how to connect 3 or more PCs using a switch. Now we are trying to connect 2 or more PCs when they are in different network. This is the topology we will discuss today. So we have two PCs, PC1 and PC2. PC1 has the IP of 10.0.0.1 and PC2 is having the IP of 192.168.0.1. So these two are in different networks. In order to connect two computers in two different networks, we need a device called router. What router will do is it can take packets from one network and move it to another network. In order to do that, routers should have IP addresses on it. Let's see. So in this topology, we have configured the PC1 with 10.0.0.1 IP. Okay. But if you see the gateway value, currently it is empty because we didn't configure any gateway. So we tried to ping an IP from PC1, ping 192.168.0.1. So what happens on PC1 is when we try to enter this command, first it will check if the destination address where it wants to send the packet, is it in the same network or different network. If it is in the same network, it will create a ARP request packet to identify the MAC address of the destination IP, target IP. But in this case, if you see, this is not in the same network as PC1. These two are in different network. So in order to send a packet to a device in another network, the packet needs to be forwarded to its gateway. Basically, PC1 cannot directly send a packet to an IP which is in the different network. So first it should send it to a gateway or a router. So the gateway also should be in the same network. For suppose here PC1 has an IP of 10.0.0.1/24. That means gateway also should be in the same network, means it should be in between this range. Then only PC1 can able to reach the gateway, right? So it should also reachable. So when I try to issue this command, what happened is, as I didn't configure the gateway, it is printing no gateway found. That means PC1 does not know where to send the packet because there is no configuration of gateway. So to give gateway configuration in GNS3 VPC device, this is the command. We give IP address. After that, we will give the gateway value. As you can see, once we entered that command, PC1 took the configuration of IP address 10.0.0.1 and its subnet mask, and it took gateway IP as 10.0.0.254. So now PC knows that if it wants to connect to any device in a different network, it needs to first send the packet to its gateway. So we can verify if it is configured correctly on the PC. You can see now gateway value is populated with the address that we have entered there. So now I try to ping the gateway, not the gateway, the PC2 IP. So what happened is, in the background, it tried to reach the gateway, means it tried to find out the MAC address of the gateway. In this case, I didn't configure the gateway on the router yet, so no one will respond for that ARP request. Okay, to forward the packet to gateway, PC needs to know the MAC address of its gateway. So for that, what it will do is it will send ARP request for 10.0.0.254 in this case. I didn't configure the gateway yet, so that's why I did not receive any ARP reply for that IP. So that's why it is printing that it is not able to reach the gateway, so it cannot send this ping packet. So in this slide, I have showed the configuration of a router. So in this lab, I am using a multi-access switch. That means it can work as a switch or router. So to convert it as a router, I need to enter these three commands. Once I have turned it into a router using the command IP routing, then I can start assigning the IP addresses to the interfaces. Interfaces is nothing but network interface cards on the router. So if you can see, PC1 is connected to Ethernet 1, so we need to configure the PC1 gateway here. So I took the last IP in the same network. The best practice is to take the first address or the last address. Okay, so here I am taking the last address, which is 254, and I am giving the no switch port command because in a multi-access switch by default interface will be in the switch mode. To convert it to a route mode, we just need to type command no switch port, and then we need to give the IP address to that interface. Similarly, I have done the same thing for the other side. So for Ethernet 2, where it is connected to the PC2, I have configured the 192.168.0.254 on this particular interface that will be used for the PC2 gateway. So now what will happen is, when we try to do the command PC1 ping 192.168.0.1, what it will do is it will check its gateway configuration, and it knows that what is the PC1 gateway. It is 10.0.0.254. So it will send a ARP request. So once it receives the reply, it will know the MAC address of this IP. So what it will do is it will then create a packet ping request. Basically, that's what we ask the system to send a packet. So source address will be 10.0.0.1 because PC1 is sending this, and destination is 192.168.0.1 because this is where we wanted to send the packet. Source MAC address will be PC1 MAC because this packet is leaving from PC1, and to destination it is the gateway MAC address, because when we put the gateway MAC address in this field, the packet will go to the gateway. Okay, so beginners will confuse that when PC1 wants to send a packet to PC2, the packet needs to go to the router, but the destination IP is not the gateway IP. Destination will be always where we want to send the packet, right? For suppose you are trying to send a normal letter through postal system. So person A sending a letter to person B. So those two persons are in different cities. When you send the letter to nearest post office, what they will do, they will check the destination, like the two address, right? So it will be person B address. You never write a letter to post office. Like the to address will never be the post office address, right? To address will always will be where you want to send the letter. So in similar computer network, in this example, PC1 is trying to send a packet to PC2, which is in a different network. Like in this example, you can think like it is a different city. So you need to send the packet to nearest post office. For that, you don't change the to address. The to address will be the PC2 IP only. In order to send the packet from PC1 to gateway, you just need to change the destination MAC address to gateway MAC address instead of PC2, because ARP only works in same network. Okay. PC1 will never send a ARP request for 192.168.0.1 IP because it's not in the same network. Okay, because ARP limited to same network only. Okay, so once PC1 creates this packet, it will send it to the wire. Then it will reach its gateway in this topology. So now router received a packet like this. What router will do? So the first thing it will do is it will check the destination IP address. Okay. So when post office receives a letter, first what they will check it, they will check the to address so that they will know where to send it next, right? So similarly, router also will do the same thing. It will check what is the destination IP. Then it will check its routing table. Routing table is nothing but it will contain entries of all the networks it knows and where to send the packet. In this example, so you can see 10.00/24 is directly connected Ethernet 1. So Ethernet 1, when we gave the IP 10.00/254/24, what router will do is router will populate this connected route entry. Okay, basically it will know that 192.168.0.24 is behind Ethernet 2. Similarly, 10.00/24 is behind Ethernet 1. So in this example, so it now received a packet with the destination IP of 192.168.0.1. So as the second step, it will check its routing table. So in the routing table, what it is saying, to send any packet to this network 192.168.0.0/24, it just needs to send the packet from Ethernet 2. In this case, it's a connected route. Connected route means the network is directly connected to this router. Okay, so if it is directly connected, what it can do is it can send a ARP request, because the destination IP is in the same network where one of the router interface is. So when it sends the ARP request, PC2 will reply back, right? When PC2 reply back with, so what will be the ARP request it will send in this case is who has 192.168.0.1. So when it sends the ARP request, PC2 will reply back with its MAC address. Okay, then what router will do is it will edit the packet MAC address field. So the source, now the packet will leaving this network and going to different network. So when it is leaving from the router, what it will do is it will change the source MAC address to its outgoing interface. So what is the outgoing interface? The packet came in here and it's going out this way. So Ethernet 2 IP address. It will change the source MAC address to Ethernet 2. And for the destination MAC address, because the PC2 is directly connected, it will send the ARP request and will get the MAC address, because ARP process works within the same network. Okay, so once it has the PC2 IP, it will replace this gateway MAC value with the PC2, and then it will send the packet to on the link. So how it will look like on the link after leaving the router? Source IP, destination IP will still remain same. Source MAC address is changed to Ethernet 2 MAC, and destination MAC address changed to PC2 MAC. Okay, because based on the routing table, it needs to send the packet towards Ethernet 2, where 192.168.0.1 is directly connected. So as you can see on the router, if you want to see the ARP entries, you can do show IP ARP. As 192.168.0.1 directly connected, it learned about that PC through ARP process from Ethernet 2. So now the packet has delivered to PC2. So PC2 received a packet like this. It has the source IP of 10.0.0.1, 192.168.0.1, and source MAC address as router Ethernet 2, because the packet came from here, and PC2 MAC address is its own MAC address, PC2. Okay, so now it received the ping request. Now it needs to respond back. As you can see, one packet traveled here with one ping request. Okay, request. Now PC2 has to send its response, ping reply. So when PC1 sent a ping request, if it receives the response back, means there are two packets exchanged in this. This is the first packet, this is the second packet. So if PC1 receives the reply, then only it will be a successful ping. Okay, so let's see the reply process. Now PC2 needs to reply back. So PC2 now need to send a packet to 10.0.0.1, because that's where it received the packet from. As it is the IP in different network, what PC2 will do, it will send the packet to its gateway. How it will know the gateway MAC address? Through ARP process. Okay, so the source MAC address will be PC2 MAC in this case. Source IP is its own IP, destination is 10.0.0.1, and this is ping reply. So this packet comes to the gateway. So now what router will do? The first step is it will check the destination IP. It is 10.0.0.1. Then it will check against routing table. 10.0.0.1 is behind Ethernet 1. Ethernet 1 here. This is the route. Then as it is a connected route means this network is directly connected to the router so that it can send ARP request and get the MAC address of that particular PC. So 10.0.0.1 MAC address it knows from the ARP process. Then what it will do is when the packet leaves from it, incoming interface is Ethernet 2, outgoing interface is Ethernet 1. So it will change the from source MAC address to Ethernet 1 MAC address, to MAC address to PC1 because it is directly connected. So now this packet will go on the link. So this is how it will look when we capture the traffic, and if we see it in the Wireshark, source IP will be 192.168.0.1, destination will be 10.0.0.1, source MAC address will be router Ethernet 1 MAC address, destination will be PC1 MAC address. So now this packet goes to PC1. So now PC1 received the response for its ping request. Okay, so as you can see in this example, for one ping, so I used the option -C1 means it will only send one ping request. Once it receives the response, this will be the response. So basically it took 26 milliseconds in my GNS3 machine to send packet from PC1 to PC2 and the response. So two packets being exchanged for this single ping request. If you don't provide -C1 flag here, it will send by default 5 pings. Basically 5 pings means 5 ping request packets, 5 ping response request. So total 10 packets being exchanged for this command. Okay, so for this class assignment is build similar topology, verify the connectivity between PC1 and PC2, verify the routing table and ARP entries on the router, and try to identify what will be the MAC address and IP address values when you try to capture it on a physical link. Okay, so if you understand it correctly and able to complete that lab, you can try to build this topology. In this topology I have taken 3 PCs on different network, and each PC has its gateway. So once you do the correct configuration, you should be able to ping from PC1 to PC2 and PC1 to PC3 as well. So verify the routing table and ARP entries on the router. Yeah, that's all for this class.